Okay, so today we're going to look at some new theorems and then also do some algebra review. So the first thing is these three theorems. They are on the notes that are uploaded, but also here they are. Pretty straightforward. If two lines intersect and these two angles right here that are adjacent are congruent, this linear pair, then the only way for that to happen is if these are perpendicular, which means there's four 90-degree angles there, or four right angles. The next thing is if a transversal is perpendicular to one parallel line, then the other line that is parallel to is also perpendicular to that same line. And the last one is that if two lines are perpendicular to the same line, then they are parallel. So kind of going backwards from the other one. So let's go ahead and start talking about some perpendicular lines. When we're finding distance from a point to a line, the distance has to be the length from the perpendicular segment to the point. So the line that goes from the point, so if we're trying to find the distance from point A to line BC, we have to go to point D and find that distance because it has to be perpendicular. Okay, so if you're given a bunch of lines, you want to look for the perpendicular line. Okay, so first of all here, I'm going to give you a reminder of the distance formula. It is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to plug in points A and D into this distance formula. And we're going to get -2 minus 0 squared. Oops, nope. Look at me. I'm doing the y's and not the x's. -1 minus -3 squared plus -2 minus 0 squared. So that becomes the square root of 2 squared plus -2 squared, which is then, let's see here, the distance is the square root of 4 plus 4, which is 8. And the square root of 8, excuse me, is approximately 2.8. Okay, so again, we're just applying the distance formula, which we learned earlier in this year, to the distance from the point A to the line BC. Let's do another one. So the first thing we want to do is think about perpendicular. We have to do perpendicular. So we're going to find the distance from point A to point C, because point C is the point on the line where this is the perpendicular segment from the point that we're finding the distance from, so point A. So again, we're going to do our distance formula. I'm not going to write it out again for you, but we're going to use it, and we're going to do +1 minus -3 squared plus -1 minus -3 squared. So we get the distance of 4 squared and then plus 2 squared. So the distance is going to be equal to 16 plus 4. And so that is the square root of 20, which is approximately 4.5. Excuse me. All right, now we are going to use these diagrams and decide if these lines are parallel. You can think back to those three theorems that we have, but we also want to think back to previous days here and the converse of corresponding angles and the converse of alternate interior. Okay, and so there's actually going to be some of these where there's more than one reason that will work. So first we want to look here at PQ and S. The only two lines that could be parallel are P and Q. But I'm looking at this transversal S, and there is nothing labeled about that intersection, and so there is not enough information. To say any lines are parallel in that diagram. So again, this is kind of from last week. This one here, I'm looking and I'm like, oh, hey, P and Q both have right angles on the transversal R. So we do know that P is parallel to Q. And you can cite that theorem that the lines perpendicular to a transversal theorem. You could say that corresponding angles are congruent and use that as your reason. There's lots of different reasons you could say that P and Q are parallel, but those are the only two. There is nothing labeled about the intersections of S with P and Q. Okay, now we're going to look at diagram C. All right, and so we know that so we have these parallel, these transversals. I'm going to tell you there is at least one set. There is actually two sets here. And so if you look at all of these, M and N they're both perpendicular to line K, and J and K are both perpendicular to line M, and so M is parallel to N, and J is parallel to K. And again, that's because of that lines perpendicular to a transversal theorem, or you could label it as their corresponding angles are congruent, or their alternate interior angles or alternate exterior angles. You have lots of options here, but there's two sets of parallel lines. Okay? All right. Looking at diagram D, this goes back to that very first theorem that was on that first slide, and it is the linear pair perpendicular theorem. And so that means that these are perpendicular right here because 1 and 2 are a linear pair, and so they are creating some right angles. Okay, oops, that's not a right angle, that is not labeled. But then we can look and we can use the same one we've been using, the lines perpendicular to a transversal theorem, and we can say that M is parallel to N, or S is parallel to T. You can also say that because of alternate interior, alternate exterior, corresponding same side interior, same side exterior, there is lots of possibilities here. Okay? All right, a couple things about slope. We're going to be doing some algebra review here because we're going to talk a lot about parallel and perpendicular lines on the graph tomorrow. So positive slope is increasing from left to right. I also think about it if there's a little guy walking on top of the line and he was going across the paper in the direction we read from left to right, he would be walking uphill. That's a positive slope. Okay. Negative would be decreasing from left to right, or if there's a little guy walking on top of the line, he would be walking downhill. Okay. This is slope-intercept form. All right. And so this is the slope. The number next to the x is always the slope, so the m. And we always talk about it in rise over run. That's going to be on another slide here in a minute. And the y-intercept is where it crosses the y-axis, okay? Lots of times people would try to put it on the x-axis. You always have to remember the y-intercept tells you on the y-axis. And the way that we know something is in slope-intercept form is if it is y equals mx plus b, or y is all by itself, okay? One other form that I would like you to be aware of is point slope form, and that's y minus y1 equals m times x minus x1. That is still the slope. Okay, and this is what we're going to use to find the slope-intercept form. We'll plug it into this and then solve for y. Okay, so first we're going to identify the slope and the y-intercept in this equation. So the slope is the number next to the x, and we have to pay attention to the negative in front. So it's negative 2/3, and then the y-intercept is negative 1. So we're going to start on the y-axis at negative 1 and go down 2 over 3. Down 2 over 3. Okay, and we can put a few more points on here and then draw in a line as best we can. My straight lines are always a semi-questionable. Okay. All right. Here is the slope formula for you, okay? Definitely write that down if you don't have it memorized, but remember it's always rise over run. So if I'm looking at a graph, this is up 6 and over 2, okay? And 6 over 2 is the same as 3 over 1, which is the same as 3. We could also plug in the points into the slope formula here and do 5 minus negative 1 over 1 minus 3, which is also going to give us 6 over 2, which will also simplify to 3. So we would get it using the formula or counting it on the graph. You should end up with the same slope. So we're going to find the slope of a line that passes through these 2 points. And so I'm going to do this, and I'm going to do y2, so 8 minus y1, which is 6. And then I'm going to do x2, which is 3 minus 2. So 2 over 1, which is the same as 2. And then we want to find the equation. So we're going to use point slope form and then get it into slope intercept form. So I'm going to write out what point slope form is. So y minus y1, that's just the first y coordinate, so 6. So y minus 6 equals, and then my m that we found is 2, and then x minus x1, which in this case is 2, and found that right there. I'm going to distribute, and I get y minus 6 equals 2x minus 4. Add 6 to both sides, and I get y equals 2x plus 2. Okay, now we are going to, sorry, I did this part up here. We're going to graph this line. So we're going to start at our y-intercept of 2, and then from there we're going to go up 2 over 1, up 2 over 1, and we're going to get our line like that. Okay? All right, we're going to do this again. We're going to write the equation. We're just not going to graph it. So again, we're going to use the slope formula and do -1 minus 0 over -3 minus -1. So -1 over -2, which is 1 over 2, because the negatives cancel out. Then I'm going to use point slope form. And I'm going to use this first point here, so y minus 0, that's our y coordinate. Our slope is 1/2. X minus our x1, which is -1. Let's cancel. So I have y equals, because y minus 0 is just y, and I'm going to distribute. So I have 1/2 x plus 1/2. And that is my slope-intercept form. And again, I know that because y is all by itself on one side of our equation. Okay, this is the last kind of new review that we're doing today. So we have this equation. We want it to go from standard form, which is what it's in, and we want it to be in slope-intercept form. So we want to solve for y and then find the slope and the y-intercept. So we're going to get y by itself by first subtracting 2x from both sides. And I get 6y equals 12 minus 2x. Divide everything by 6, and I get y equals 2 minus, and 2/6 simplifies to 1/3. And I'm going to rewrite it in slope-intercept form with the slope and then the y-intercept. So our slope in this equation would be -1/3. And our y-intercept, or our b, would be 2. Okay, I would like you to try these two problems on your own. I'm going to write the answers on here and share them with you. So pause this right now, try and use the slope formula and find the equation for the line in number 1, and then try and solve for y in the second one and find the slope and y-intercept. So again, pause this now and try these, and I'll put the answers up in a moment. Okay, so here's the work for number 1 and number 2. So here's our equation for the first one. Oh goodness, come on. There we go. And then here's the equation and the slope and y-intercept for the second one. And if you are still listening and you have questions, please email me. And also, if you are still listening and you want an extra credit point on this assignment, please email me and tell me what your favorite day of the week is and why. What is your favorite day of the week and why for an extra credit point? So email me and tell me your favorite day of the week if you're still listening.